Hello, my Tech Time friends. This is Mrs. Evans here coming to you to teach you about the slope formula. The slope formula states that m, slope, is found by finding y2 minus y1, the change in y, over x2 minus x1, the change in x. Now, excuse me, last week we found the slope by plotting the points on the coordinate plane and just counting the boxes or counting the steps. But sometimes you don't have a coordinate plane. You simply have 2 points like we have here. And are you going to graph all these points when you want to find the slope? Of course not. Who's got time for that? So there is a way to find the slope without having to graph them all the time. However, to get us started, I'm going to show you how this relates to what we did last week. So our 2 points are 4, 3, and 8, 6. Here we have 1, 2, 3, 4, and then 1, 2, 3. So 4, 3 is right here. 5, 6, 7, 8. 4, 5, 6. So 8, 6 is right here. Now you and I could both count the boxes and just go, okay, from here, this is where they meet. 1, 2, 3. Rise over 1, 2, 3, 4. And say, okay, I know my slope is 3/4. Done. This slope is 3/4. However, again, like we said, we're not always going to have a nice coordinate plane to help us out with this process. So we have to be able to know how to do this with just points or just using a table. And so right now we're going to focus on just the points. So we have this formula, y2 minus y1. Well, if you remember, x is always listed first, y is listed second. X is listed first, Y is always second. And it genuinely doesn't matter which one is X1 and which one is X2, as long as whichever one is X1, the Y next to it is Y1. So because these are listed first, we're going to call this X1, Y1, X2, Y2. Okay? So to use our formula, y2 minus y1 over x2 minus x1, I'm going to use 6 minus 3 over 8 minus 4. That shows me y2 minus y1 over x2 minus x1. So 6 minus 3 is 3. 8 minus 4 is 4. Therefore, m, or slope, or the rate of change, or the change in y over the change of x, is 3/4. And that's exactly what we found when we did it up here with the coordinate plane. 3/4, rise over run. So let's do another one. Find the rate of change. Again, it's the same thing as saying find the slope or find m. So here we have y2, y1. So y2 is 5 minus y1, which is 3, over x2, which is 7, minus x1, which is 1. Therefore, 5 minus 3 is 2, and 7 minus 1 is 6. Now, if I were to plot this on the coordinate plane, I wouldn't get 2 and 6. we have to simplify this first. We always have to put this in the most simplest form. So 2 can be divided by 2 one time, and 6 can be divided by 2 3 times. So our true slope, our true rate of change is 1/3. And that's a very important point that you always, always simplify. Okay? I would like you to pause this video and do the next one or two, and then turn the video back on and watch me do them, and you can check your work. Pause the video, please. Okay, I'm assuming you've turned it back on and you have done at least the next one. If not, you've attempted it. So again, our slope formula is y2 minus y1. So 7 minus -2. Notice I had to put that -2 in parentheses to separate it from the negative sign. The -2 is the negative sign is the quality of the 2. The minus sign between them is subtraction. It's the operation. They're different. And then we have x2 minus x1 to minus -1. So now we have to draw on your memory back to 7th grade to see if you remember how to subtract negatives. So we know the signs for positive, same signs, add and keep, different signs, subtract, keep the sign of the larger number, then you'll be exact. But that is for adding. Those are adding integer rules. In order to change a subtraction problem so that you can add, you have to change it to an addition problem. So here we're going to take this 7 and keep it. Then we're going to change it to an addition problem. But in order to make that work, you've got to find the opposite of -2. The opposite of -2 is what's on the other side of 0. And that would be +2. So if it's 2 spaces from 0 here, it'll be 2 spaces from 0 here. The opposite of -2 is +2. And now you can do your math. Again, same thing. Keep it, change it, flip to the opposite. 2 plus 1 is 3. Now, we're not done because we have to simplify. 9 can be divided by 3 times. Therefore, my slope, my rate of change, my change in y over change of x is 3. Okay, so if you didn't get that and you want to try again, you can again pause it, work on number 4, and then turn this back on when you're ready to check your work. Okay, so now I'm going to do number 4 for you. Again, the change y2 minus y1, which they happen to be the same, all over x2 minus x1. We're going to keep it, change it, opposite, and we're going to get a 0. And we're going to divide this by 5 minus 3 is 2. And now this is what we call 0 slope. If you recall last week, we talked about the difference between 0 slope and undefined slope. So if I were to quickly sketch this, and I'd say 3, 1, 2, 3, and -2, 1, 2, and 5, 4, 5, and -2. I'm going to have a straight flat line at -2. And we know that when we have horizontal lines, we have 0 slope. Not undefined, that's when it's vertical. This is 0 slope. Okay? So due to time, we're going to just jump down to number 8. And we have y2 minus y1 over x2 minus x1. Now I can already see we're going to have a smidge of an issue here because 9 minus 9 is 0. And I know that any fraction or slope with a 0 in the denominator creates a situation that is undefined. If we were to graph this one, somewhat like we did the other one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where x is, and y is -1, 2, 3, 4, 5. So that is 9 and -5. And then we also have 9 and +1. What do you see? A vertical line. And we know that when we see a vertical line, it's undefined. Okay? So 0 in the denominator, it's undefined. 0 in the numerator, it's 0 slope.